All right, guys, welcome to the notes. This is day one of 83385. These are the makeup notes for the ones that are in class that were out of sync. So these should be in sync if everything goes correctly. So I'm going to go a little bit quicker just because you've kind of seen it once, sort of. So the first property we're going to talk about for exponents is multiplying powers. What we're going to find here is if we have like bases of a, or any value, and we're going to multiply the exponents. And the result's going to be the same base, a, but we're going to add these exponents. Okay, so this is going to end up being addition of exponents. Okay, now if we look at power to a power, so we've got some base, and it can be raised to a power or not. Power of 1 or power of 10, 6, 5, doesn't matter. And it's raised to another power. To simplify this, we're going to take that base, and these exponents are going to be multiplied. So m times n. So power to a power means that we multiply exponents. Product of a power is when you have multiple bases that are raised to some power. So we've got two bases, could be 3, 4, or 5. Each base in there, each variable or number, that's what a base is represented there, gets raised to that power. So in this case, both a is raised to the n power and b is raised to the n power. And the negative exponent property was something we were familiar with yesterday. We found that if it was negative, we flipped or reciprocated the base and moved its position to the denominator or numerator and took away the sign. So we also saw that happen from the denominator. So we could see something that looks like this if we had 1 over a to the negative m. In that case, it would move to the numerator and become a to the m. So we've seen that one yesterday. So let's use these properties, and we'll do a couple quick examples here to show you how they work. So here's like bases of a number, not a variable in this case. So two numbers, 11 is a like base, and they're both raised to a power of this first one being raised to a power of 4, the second one being raised to a power of 3. What we do then is we take the same common base, and we take the exponents and we add them. So 4 plus 3. And then we'll clean that up. I don't expect you to write that first step, but I'm going to write it so that you can see it. So let's see one with 3 like bases. Here's 2 as our base, and we've got 3 exponents, a 5, a 2, and a negative 1. We're going to write them as one common base, and we're going to take all of the exponents and add them up. Again, I'm writing this out so that you can see it. So we get 5 plus 2. And let me write that a little bit different so that you can see it. It'll be 5 plus 2 plus a negative 1. It's still a subtraction, but I wanted you to see that we are adding all of them. We're not really subtracting, we're adding, but since we're adding a negative 1, it looks like a subtraction. So what we'll find then is it's going to result into 2 of 5 plus 7 minus 1 is going to give us 6. We don't have to expand these two because the directions don't tell us to. They just want to see us write it as a single base. All right, so let's jump down here and see that with variables. Property still operates the same, so we've got 3 like bases here. This is in terms of variables though, so we've got x squared, x to the first power. Don't ever assume that that's 0. There'll always be 1 as an exponent, because we know anything to the 0 power is 1. And we've got x to the 4th. So we're going to take that, write them as one common base, and we're going to take all the exponents and add them up. So 2 plus 1 plus 4, and then the result ends up being x to the 7th. Okay, let's see one with like bases and coefficients. Okay, so this is our first introduction to coefficients. I think with some of these rules, what you want to think of is that these numbers are just being multiplied. They both have an exponent of 1. Don't worry about that. But what we're going to do with the coefficients is we're going to take them and put them in front because that's where we like coefficients to be. And we're going to take our bases, and because it's like bases, we're going to add our exponents. So this will be n to the 5th minus, or I'm sorry, I guess plus a negative 2, just so I can show it out right. We'll multiply the coefficients at this point because they are like terms, so they can be multiplied together. So we're going to get 6n to the 3rd. Okay? All right, so let's do another example here. This is we have different bases. So all the ones we've done so far have common bases. Now we've got a c as a base, and this time we have a d. So what you can't do is combine all of them. You do have to keep them separate. So c we'll write first. We're going to take c to the 4th here, and we're going to add this exponent of 2. So c to the 4th plus 2. And our d value, it has a negative, but we'll clean that up in the next step. We don't want to do too much in each step, so we want to do one thing at a time. So we get c to the 4 plus 2 times d to the negative third. So if we clean this up, we're going to get c to the 6th and times d to the negative third. Now let's take care of that negative 3 value. Remember, the negative exponent tells us to take that in its base and move its position, in which case it's going to go to the denominator. So c is going to stay in the numerator, so c to the 6th divided by d to the 3rd power. And again, now it becomes positive because we moved its position. Let's do one with coefficients. So again, we have two like bases, which of x, right? X to the 1st power here, and x to the 8th. We don't have a like base for the y's, so it'll kind of hang out, but we do have 3 coefficients. We like to move those into the front, so it'll be 5 times 2 times 3. Let's put our x variable next, or x base. Let's put that next, and then we know that multiplying like bases with exponents, they add. So we're going to take 1 plus 8. And then our y is kind of hanging out, so y to the 4th. All right, so we'll take these together. So 5 times 2 is 10, times 3 is 30. Let's clean this up, our value of x. So it's going to become x to the 9th, 1 plus 8, times, or I guess I don't need to write the multiplication symbol, at y to the 4th. All right, and then that one is now simplified. Let's see this in scientific notation. With scientific notation, we're going to treat this as our coefficient, as this is 7, and this 4 is our coefficients. And our base then, our like base, is going to be the 10 to the 2nd power and 10 to the 5th power. So we're going to kind of treat them like that, even though we could multiply them all together, but that wouldn't preserve that scientific notation. So we want to keep it that way. So let's move our coefficients to the front and multiply them like we've been doing. Let's put our multiplication symbol there to keep the scientific notation going, times 10, and then let's add our exponents, 2 and 5, so 2 plus 5. Let's clean it up a bit. So we get 7 times 4, which is 28, times 10 to the 7th. Now looking at this, we'll notice that this is not in correct scientific notation. What we know that is that we get some value times 10 raised to some exponent. That's scientific notation. Now here's the part we have to pay attention to. That first value, has to be between 1 and 10. That's what we learned. So to keep that true, 28 does not fit. To make that fit, we're going to have to move this decimal place over 1 to make it 2.8. When it's 2.8, it is or will be in scientific notation. Now let's look at this value here to help us out. This is times 10 to the 7th, which means it's going to be a very large number. It means that this decimal place has to move 7 places to the right. 1, 2, 3, 4, 5, 6, 7. That's the number it would be with 7 zeros, so 280 million. But notice what we did to turn it into the correct scientific notation. We had to move that decimal place over here between the two, essentially making it one more move to the right. So instead of times 10 to the 7th, we're going to take, and it'll end up being 2.8 times 10 to the 8th, because it has to move one more position to get to this spot here to make the correct answer. All right, so let's move on to some other examples here. Let me get my screen to move. There we go. We'll scroll down here. Now we're going to check power to a power exponent properties. In this one, we can see we have a base raised to some power or degree of 3, but that whole thing then is raised to a power of 6. What we found out was that we take and we multiply our exponents in this scenario to get the correct simplification. So this is going to end up being x to 3 times 6, which is 18. Okay, I don't think we need to see another one of those. Let's see one with a little bit more going on. So here's one. And we'll do one of these also. So we notice that there's two bases here, and we've got power to a power. So we've got multiplication of like bases, so we're going to add exponents, but we also have to first deal with, and especially since there's parentheses here, these are telling us that we have to address this first. We have to take this -2 and multiply it to this 3. So let's write this c to the 5th. Nothing's going on with that right now. And we're going to take and do power to a power. So c to the 3rd times -2. Okay, so we addressed this portion first before the other portion. We couldn't have dealt with this c to the 5th yet. So let's rewrite this c to the 5th because nothing's happening to it yet. And we're going to end up cleaning this up. So c to the 3 times -2 is going to be -6. Now we can do multiplication of like bases, which means that we're going to add exponents. So we're going to end up with c to the -1st power. We can't leave it like this. Even though it's cleaned up, we've got all of our bases combined into one common base, we can't have a negative exponent. So that has to be changed. And we know that negative exponents tell us to move positions. Okay, so let me erase this equal sign. And we'll start over here so I have a little more room. So equals 1 over c to the first, or c. And that's the resultant product. So we're all set and done there. Let's move over here and do 12 and try a new one. Again, same thing, like bases. We can't deal with this one first because we have to deal with this exponent, or these parentheses here. And so we get power to a power. So n to the 4th power times 3 times that n to the 5th, because nothing's happening to that n to the 5th right now. N to the 4 times 3 is n to the 12th. And now we've got n to the 12th times n to the 5th. And that's multiplication of like bases, so we're going to end up with n to the 17th. All right, let's do a couple more. So now we've got power to a power, but we'll notice that there are two bases in here, two parts of the expression. We've got a constant of 2, and we got a variable of z. Both of these have to be raised to the power of 4. Both, or all. There could be 100 of them. Every one would have to be raised to a power of 4. Let's take a look at that. 2 is raised to the 4th power times z to the 4th power. All right, so we've got 2 to the 4th and z to the 4th. And this one, it doesn't say just write them in like bases. It actually does say simplify. So in that case, when we're simplifying, this 2 to the 4th can't stay this way. So we know 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2 is 16. So we get 16z to the 4th. Okay, let's take a look at this number 14 here. And we'll notice again, two parts to this. So we've got a 4 and a g that both have to be raised to the negative 2nd power. Let's approach this a little bit different from the last one where we went ahead and raised both of them to the power. Let's address this negative first. What this negative is telling us to do is to take this whole piece and move it to the denominator. So let's do that first before we do power to a power. So the 1 will hold the numerator's position because there's nothing left. And 4g to the 5th power will be moved to the denominator, and then all raised to a positive 2 now because we dealt with the negative. Now we can do power to a power and address that portion of it. So 4 gets raised to the 2nd power, and g does, but power to a power says that we multiply those exponents, so 5 times 2. So if we clean this up, we get 1 over 4 squared, which is 16, g to the 5 times 2, which is 10. All right, so let's move down here and tackle one last problem. We're going to take a look here. We've got a multiple things going on at this point. We can see we've got a power to a power, right? And we can see we have a second power to a power here. So we've got two powers to a power, and we've got multiple bases, so different terms. We've got a constant, an x value, and a y value. So we've got a lot of things to look at here. Let's try to take it as few steps as possible, 1 or 2 steps at a time, and then we'll rewrite. All right, so let's address this power to a power first. So this is going to be x, and again, we multiply them now. So negative 2 times 2, that's going to be multiplied. And again, let's address this power to a power right now. 3, which is raised to the 4th power. Remember, everything inside of there gets raised to the 4th power. X to the 4th power, and y. But y has that squared, so it's going to be 4 times 2, because power to a power is a multiplication. So now that we've got that written down, let's clean it up and kind of see where we go from here. These two multiplying together, so we're going to get x to the negative 4th as our power. 3 to the 4th, we can actually probably clean that up. I think if you remember we did this, this should be one common that you should be familiar with, which is 81. X to the 4th, times x to the 4th, because nothing's happened to that. And let's clean this y up at the same time. So y to the 2 times 4, which is going to be 8. So now let's go to the next step, which is multiplying like bases. So we've got bases of x here that need to be put together under one unit. Our constants need to be in the front, so we're going to move this 81 out front, and then we're going to take and combine these under one base. So times x to the negative 4 plus 4. Okay, and then finally that y is going to drop down. Nothing's going on with that y, so it'll be times y to the 8th. Okay, and we're almost done at this point. You'll notice that x to the negative 4 plus 4, that's going to turn into x to the 0. And I think we're all comfortable with the fact that x to the 0, or anything to the 0 power, turns into 1. So it turns into 1, and anything times 1 is itself. So we actually don't see it. It looks like it drops out, but really it's just a multiplication of 1. So it's gone, and then we'll add in our y to the 8th, and then that's our result, is 81y to the 8th. All right, so I've done a couple examples of each to kind of repair what we happened today. One correction here is this should be 413. Page 413 was the correction, not 403. Hopefully you got that on the community page, but I'll post it again. All right, thanks all. We'll see you tomorrow.